We are about to implement the explosion effect for when the bomb hits the car. First, let's create the visual blast of the explosion. We are using a pre-existing firework image for this. The sprite's dimensions are 16 by 16 pixels. Here, we only need the upper part of this image, so let's change the height from 16 pixels to 5 pixels. As usual, we will create an array to store these explosion sprites. Let's name this array listExplosion. In the outer loop, which executes once for every column of bombs, we will create the explosion sprite and add it to the listExplosion array. Next, we need to position these explosion sprites accurately. Adjust their locations using the offset so that it appears as if the car is being hit and is exploding. After several adjustments, the explosion effects now look appropriate. Now the logic to decide whether the bomb hit the car. Drag the if block. Here the player location needs to be under the current column, so it should be equal to column plus 1. And this column needs to have a bomb at the bottom of the column, so in this update frame it will collide the car. At the bottom means the index equals to 0. Visible equals to true. So if both the above conditions are met, we show the explosion sprite. That is, the sprite at index column of array listExplosion. Invisible shall be off. Let's test. Works, but need more functionalities. To display the explosion of the car for a certain interval, we need to change the game to a state where the player cannot control the car. That is, not in the playing state. Therefore, we create a variable named GameState to represent the current state of the game. When the game starts, it should be in the playing state. Returning to the function updateBomb call, when the car is hit, the game should transition to the exploding state. We will introduce a countdown at this point, so the game knows when to exit the exploding state and spawn a new car. Drag the Start Countdown block, and set the duration to 2 seconds. In the canvas, locate a suitable area and drag the On Countdown End block into place. When the countdown ends, actions will depend on the game's current state. If the game state is set to exploding, we'll need to change it back to playing and spawn a new car. Now, copy the block that makes the current car sprite invisible. Also, use the block that resets the player's location back to the starting point. Additionally, set the first car sprite to visible. And don't forget to make the explosion sprite invisible as well. Let's test our progress in the simulator. It appears to be functioning correctly. Our game now features a moving car, a flying plane, falling bombs, and the bombs can even destroy the car. Next, we will enable the car to score points once it reaches the right side of the screen. In the On Right button pressed event, check if moving right has brought the car to the final position at the bottom of the screen. This is determined when the player's location equals the length of the car sprite list -1. At this point, we will change the game state and initiate a countdown. Let's set it for 1 second. The new game state will be scoring. Let's add an effect to the car when it scores. We'll use the blizzard effect, with a duration of 1 second. In the on countdown end event, add a branch for the scoring countdown. When this countdown ends, and the game state is scoring, we will need to reset the player's location. But first, make the car sprite invisible. Then, after resetting the location to 0, make the car sprite visible again. We should also add to the score. Let's award 100 points. In the scenario where the car is hit, after the explosion, we will change life by -1. If all 3 lives are lost, which occurs in the on life 0 event, drag a game over block into this section and set it to the lose condition. Test this setup in the simulator. It seems to work, but there's an issue. The car can still move after being hit, which shouldn't happen. To fix this, go to the on right button press event and add a condition. This condition ensures that the right button only functions when the game state is playing. For the on left button press event, let's take a slightly different but equivalent approach. Utilize the existing if block to check if the game state is playing. Add an end block, and in addition to checking if the player location is greater than 0, also verify if the game state is equal to playing. Testing the game now. Oh, it seems we've overlooked something. Once the car scores, it becomes immovable. This issue likely arises because we forgot to reset the game state back to playing. In the on countdown end event, specifically within the scoring branch, add an action to set the game state back to playing. Let's check this adjustment. Now, it works perfectly. Next, let's implement the bridge feature from the original plane and tank game. First, select a sprite to represent the bridge. Here I am using a clam sprite as the bridge. The kind, let's call it util for utilities. Create a new array named listutil to store these utility sprites. Then, duplicate this block to position the bridge sprite at an appropriate location. After some trials, and we also adjusted the location of the last car sprite. When the placements seem appropriate, we'll add the bridge sprite to the listutil, similar to how we handle other sprite types. The bridge will need to be drawn and then become unavailable. So, let's add a sprite for the drawn bridge. Here, we'll rotate the bridge sprite 90 degrees counterclockwise. Then, adjust its coordinates to ensure the drawn bridge is correctly placed. Continue fine-tuning the positioning of both the car and bridge sprites until the layout is satisfied. And, remember to add the second bridge sprite to the list too. In the next and final part of our tutorial series, we will control the toggle of the bridge and add sound effects to the game.